Okay. Hi everyone. So first of all, let me know, is audio and video are clear here? Is audio and video clear? Yes or no? So due to some technical problem, it has delayed for 10 minutes here. So due to some technical issue, it has delayed for 10 minutes. So sorry for that. Okay. Okay. Yeah. So good morning to all. Okay. Okay. So we will start our session here, that is analog circuits. Analog circuits. See here, in the previous sessions here, in the previous sessions we have seen the difference between the linear circuits and non-linear circuits. So what will happen whenever you are operating the circuit in linear region, and what will happen if you operate the circuit in non-linear region. So these things we have seen here in the previous sessions. So we have seen that whenever you are operating the circuit in linear region, okay, so what we got here, the output will be exact replica of the input but with multiplied by some scaling factor k, right? Okay, so whenever you are operating the circuit in the linear region, suppose if you operate the circuit here, if you operate the circuit in non-linear region, we have seen that the output is not exact replica of the input here. It is a distorted waveform. Yes or no? We are going to get a distorted waveform. Here distorted means the shape of the output is not same as what? Is not same as input. So the output waveform shape is distorted when compared to input. Right? Okay, so that's what I mean by distorted output signal. So whenever you are applying the signal, to non-linear circuit, whenever you are applying the signal to non-linear circuit, or you can say whenever you are operating the circuit in non-linear region, so if you apply the input signal, let us assume you have applied a sinusoidal signal here. Let us assume you have applied a sinusoidal signal like this. Right? Okay, so let us say this non-linear circuit behavior is given by this transfer characteristic here. I am drawing the transfer characteristic. Transfer characteristic is going to give you what? Is going to give you the relation between what? The relation between output and input. So let us say the transfer characteristic of this non-linear circuit is given in this manner. Let us assume the transfer characteristic is like this. So here it is 0. Output is 0. Okay, when input is less than 0, output is also 0. So as input goes on increases, output is also increasing. Let us assume this nonlinear circuit, the transfer characteristic of this circuit is in this manner. So that means what here, whenever you apply an input signal, let us assume this is a sinusoidal signal. Okay, so whenever you apply this signal to this nonlinear circuit, so its behavior is given by this transfer characteristic, the relation between output and input. So here this is nothing but output is equal to what here? Output is equal to some k times of something, some input. Okay, so now here at the output, what we can expect here? So whenever input is less than 0 here, here we are getting output is equal to what? Output is equal to 0. Now as input goes on increases, whenever input becomes greater than 0, output is equal, output is equal to k into some scaling factor here. K is nothing but some scaling factor. Okay, some k into input. So that means you can draw now the output waveform here. So what is the output waveform you can expect here? So this is with respect to time. Okay, so this is input waveform here. With respect to time. So what is the output waveform that you can expect? Tell me. So whenever input is positive, okay, that means whenever input is greater than 0, output is following the input, but multiplied with some scaling factor k. So that means you are going to get this total positive half cycle here. This total positive half cycle is going to get at the output, right? Okay, so here you are going to get the total positive half cycle at the output. Right. Okay. Next, whenever the input, if you are having negative half cycle here, whenever you are having negative half cycle at the input. So what is the output here? That means here input is less than 0. When input is less than 0, output must be what? Output is going to 0. Output is going to 0. So during this negative half cycle, from here to here, the output will go to what? The output waveform will go to 0, right? Okay, again during positive half cycle, output will follow the input. Output will follow the input. Right. Okay. So like this. So this is the output waveform that we are getting. So here the input waveform is pure sinusoidal signal, whereas output waveform is a distorted. Distorted means it is the shape of the output waveform is not same as what? Input waveform. Input waveform. So we are getting some distorted output here. Right. Okay. So whenever Y here, Y means this circuit is a non-linear circuit here. This circuit is nothing but a non-linear circuit. So whenever you are operating with the non-linear circuit, the output will get distorted from what? Distorted from input. Now if you observe here, this signal is having only one frequency component, right? This signal is having only one frequency component. Let us say that is F0 here. Okay, but here, whatever the output waveform that we got, okay, so we can represent this signal here. We can represent this signal as a that means this signal is going to have what? This signal is going to have harmonic frequencies or not? Yes or no? This signal is going to have harmonic frequencies. This signal is going to have harmonic frequencies. See, you have studied here. You have studied in signals and systems that any non-sinusoidal periodic signal, can be represented as what here? Can be represented as linear combination of harmonically related sinusoids. Yes or no? You can represent any non-sinusoidal waveform. You can represent any non-sinusoidal periodic waveform as a linear combination of harmonically related sinusoids, right? Okay, so that means what here you are going to have what? This is nothing but what? This is nothing but a non-sinusoidal waveform, right? This is non-sinusoidal waveform. So this non-sinusoidal waveform can be represented as what? Can be represented as linear combination of harmonically related sinusoids, right? Okay, so that means in this signal we can represent this signal as a combination of what? Combination of harmonic frequency signals, as a combination of harmonic frequency signals, right? Okay, so from where we are getting this harmonic frequencies here? From where we are getting this harmonic frequencies? We have applied only this frequency here, yes or no? But at the output we are getting a signal which is a combination of harmonic frequencies, right? From where we are getting this harmonic frequencies? What is generating these harmonic frequencies? That is nothing but this circuit or not? We have processed this signal through this circuit. So this circuit is generating on its own some harmonic frequency components that is going to get added up with the input signal. So whenever harmonic frequencies gets added up to the input frequency signal, then automatically the output waveform will get what? Will get distorted, right? Yes or no? So a non-linear circuit is going to generate what here? Harmonic frequency components that are going to add up with the actual frequency component, and hence you are going to get what? You are going to get at the output, you are going to get a non-sinusoidal waveform, that is a distorted waveform from the input signal, right? Okay. Okay, yeah. So that means a non-linear circuit will always generates what here? It always generates harmonic frequency signals, harmonic frequency signals, right? So because of the generation of these harmonic frequency components, the output waveform will get distorted. Okay. So that's what this non-linear circuit is doing here. So these things we have studied here. These things we have studied in the previous session. So in order to explain that clearly, I have taken one example and explained the behavior of non-linear circuit. So this is what happens whenever you are operating the circuit in non-linear region. Okay. So is it clear here? Is it clear? Tell me here. Rohan. Okay. Is it clear? Is this point clear here? Yes or no? If it is clear, we will move on to next one. Yes? Right. Okay. 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 So I hope it is clear here. I hope it is clear. Next, we are going to start. Next, our aim is to analyze the rectifier circuits here. So in order to analyze the rectifier circuits, okay, we need some basic concepts here. We must understand clearly what do you mean by a DC signal, what do you mean by a pure AC signal, and what is meant by average value, what is the purpose of average value, why we have to calculate that, and what do you mean by RMS value, why we have to calculate that. So all these things must be needed in order to understand the rectifier circuits here. Okay, so we will go through each and everything here clearly, right? Okay, so first I am going to define what do you mean by pure DC signal. What do you mean by pure DC signal? What do you mean by pure DC signal? Okay, see that DC signal, pure DC signal means it may be what? It may be DC voltage signal, or it may be current signal, right? It may be voltage signal or it may be current signal. Okay, so now if you take a circuit here, let us consider a simple circuit. Okay, here I have applied a DC voltage. Now here you are having some resistor here. Let us say, right? Okay. So now, what happens here? So here the current is going to flow in clockwise direction. The current in the circuit is going to flow in clockwise direction, right? Okay. So now here, for any instant of time here, as time progresses, the polarity of the voltage signal is not going to change. Right, yes or no? So that is called as DC voltage signal, right? Okay, so the polarity of the voltage signal is not going to change with respect to time. Always here it is going to be plus and here it is going to be minus. This will continue forever, okay, for all time. So that means I can represent here this voltage signal with respect to time, Let us assume I have applied this voltage at t is equal to 0 here. I have applied this voltage at t is equal to 0. Okay, so then this voltage is not going to change its polarity. So for all the time it is going to have a constant value, right? Okay, so this is the voltage signal here. Let us say this is V, right? Okay, so this is nothing but a pure DC voltage signal. So what is the property here? What is the property of pure DC voltage signal? One is what? It is not going to change its polarity throughout the time, throughout the whole time here, and it is going to be constant. With respect to time. Yes or no? So first point is what here? The polarity of voltage signal. The polarity of voltage signal is constant with respect to time. That means the polarity is not going to change with respect to time. And what is second one here? The value of the voltage. Is also not going to change with respect to time. Yes or no? It maintains constant value, right? Okay, so the value of the voltage, is not going to change with respect to time. Okay, the value of the voltage is not going to change with respect to time. That means it is constant. It maintains a constant value with respect to time. Okay, so if these two conditions are satisfied here, then we call that signal as what here? Pure DC voltage signal. Right? So what do you mean by pure DC current signal here? See, for all the time here, for all the time, if you observe the current is going to flow only in clockwise direction or not? Yes or no? That means the source is going to pump the charge carriers. The source is going to pump the charge carriers in the circuit. Okay, only in what? It is going to pump the charge carriers, and those positive charge carriers are going to flow in clockwise direction for all time, for all the time. That means the direction of current will remain same for all time t, for all time t. Right, the direction of current is not going to change, for all the time t. Understood? Okay, so here I am drawing for pure DC current signal here, for pure DC current signal. So this is with respect to time here. Okay, so pure DC current signal. So this is pure DC current signal. Let us say I. So what are the properties of pure DC current signal here? What are the properties of pure DC current signal? First one is what? Its direction. The direction of the current. The direction of the flow of current. The direction of the flow of current is not going to change, with respect to what? With respect to time. So this is one thing. Okay, always it is going to flow in only one direction, right? Okay, next, second one. What is another property here? The value of the current signal. The value of the current is constant with respect to what? With respect to time. So if it satisfies these two conditions here, then we can call it as what? We can call it as a pure DC current signal. Right? Okay. So what do you mean by pure DC voltage signal, and what do you mean by pure AC voltage signal here? So voltage signal is not going to change its polarity with respect to time. A pure DC voltage signal is not going to change its polarity with respect to time, and it is going to maintain the same value of the voltage throughout the time. Okay, next, similarly, current here. A pure DC current is going to flow only in one direction through the whole time here. Okay, whatever the time you can take. So throughout the time, the direction of the flow of the current is not going to change. Understood? And the value of the current is constant with respect to time. So if it satisfies these conditions here, then we can call here as pure DC voltage signal. This one we call it as pure DC current signal. Okay, so I hope these points are clear here. See, I will give you one example here. See here, if I consider a voltage signal here, let us say this is time t, so this is voltage signal V of t. Now if I consider the voltage signal like this, here, if I consider the voltage signal like this, can I say this is pure DC signal? Can I say this is pure DC signal? No. Why here? For, let us say this is voltage. Okay, so what is the condition to consider the voltage signal as a pure DC voltage signal? What is the condition? The polarity of voltage signal is constant with respect to time. Now here the polarity of voltage signal, here it is positive, here it is positive, here it is positive. That means the polarity of voltage signal is not changing with respect to time. That means it is satisfying this condition here, right? It is satisfying this condition, but it is not satisfying this condition. That is, the value of the voltage is not going to change with respect to time, but here the value of the voltage is changing with respect to time, and hence you cannot call this as it is not a pure DC signal. It is not a pure DC signal. Okay, the polarity of the voltage signal is not changing. The polarity of the voltage signal is same. Here it is plus, here it is plus, here it is plus. The polarity of the voltage signal is not changing, right? But it is not maintaining a constant value. It is not maintaining a constant value of voltage with respect to time, right? And hence it is not a pure DC signal. It is satisfying only this condition, that is the polarity of the voltage signal is constant with respect to time. Okay, and hence, but it is not satisfying the second property. So that's why it is not a pure DC signal, but here it is satisfying only one property of the DC signal. So simply we call this as pulsating DC. We call this as what here? Pulsating DC. So that means why we are calling it as DC? Because it is satisfying this property of the signal here, that is the polarity of the voltage signal is constant with respect to time. So it is satisfying, that's why we are calling it as DC. But why we are calling it as pulsating here? Because the value of the voltage is changing with respect to time, right? The value of the voltage is changing with respect to time. That means it is not maintaining the constant value of the voltage with respect to time. It is changing with respect to time. It is pulsating, right? Okay, so that's why it is called as pulsating DC signal. It is called as what here? Pulsating DC signal. Okay, it is not called as pure DC signal. It is called as pulsating DC signal. Okay, okay, yeah. Okay, if you draw instead of a voltage signal, you can analyze in the same manner for what? For current signal also. If you consider I of t, okay, if I consider the signal like this, so here also the direction of the current is not changing with respect to time, but it is not maintaining the constant current with respect to time. Yes or no? So the value of the current is changing with respect to time, but the polarity of the current, that means the direction of the current is maintained constant with respect to time. So it is always positive or not? Yes or no? The direction of the current is same. The direction of the current is same throughout the time, but it is not maintaining a constant value of current throughout the time. Yes or no? So here we can say it is pulsating DC. This is also pulsating DC current signal. Right? Okay. Okay. So I hope it is very clear here. What do you mean by pure DC signal? It has to satisfy two conditions. One is what? If it is a voltage signal, the polarity of the voltage signal must be constant with respect to time, and also the value of the voltage must also be constant with respect to time. Similarly, if you are defining a DC current signal, then the direction of the current must be same with respect to time, and also it has to maintain the constant value of the current with respect to time, right? Okay, so if it satisfies these conditions, then we can treat that signal as pure DC signal. Okay, is it clear here? Is it clear? Shubham Pandey, sir, previously you taught in which institute? I have taught in ESE Academy and Gate Forum here. I have taught in ESE Academy and Gate Forum, and also in some other institutes also. Okay. Okay. I have given everything about myself in the starting video here, in the introduction video. I have given that. Okay, you can go through that if you want. Okay. So I hope it is clear here. What do you mean by DC signal? Pure DC signal, right? Okay. Okay, yeah. Next. Next here. Next we will see what do you mean by pure AC signal here. What do you mean by pure AC signal? What do you mean by pure AC signal? We have seen what do you mean by pure DC signal. Now we will see what do you mean by pure AC signal, right? Okay. Okay, yeah. See here. Now if suppose I am taking the circuit here. Let us say I am applying a pure sinusoidal signal here. Let us say I am applying a pure sinusoidal signal, that is Vn. Okay, so here I am considering a resistor. Here I am considering a resistor here. Okay, so let us say this is pure sinusoidal signal. Pure sinusoidal sinusoidal signal. Let us say sine waveform or something. Okay. So here I am drawing that sinusoidal signal. Yeah. Here I am drawing that sinusoidal signal. Let us say this is with respect to time. Okay. So now here v of t I can represent here as, okay, so here also I will consider v of t. Okay. So let us assume okay. Now I have taken only one period of time here. Okay. So it will continue. So let us say this is t by 2 and this is t, right? Okay. So here pure AC signal, the first property of pure AC signal must be, it must be periodic here. It must be periodic in nature. It must be periodic in nature. That means whatever the signal that you are going to see over a time period t, the same signal is going to get repeated, for the next time intervals also, right? Okay, that's we call it as what here, periodic in nature or periodic signal. So for pure AC signal, the first condition must be what here, it must be periodic in nature. Next, what is the second condition here? We will see here. If you consider the voltage signal here, what it is going to do here? It is going to change its polarity, right? So initially if it is plus and here minus, it is going to pump the current in clockwise direction. Right? And whenever after half period of time here, its polarity is going to change, and in this case it is going to pump the current in anti-clockwise direction. So it is going to pump the current in clockwise direction for t by 2 time, and for next t by 2 time it is going to pump the current in anti-clockwise direction. So that means for every t by 2 here, the signal is going to, that means the voltage signal is going to change its polarity. The voltage signal is going to what here? It is going to change its polarity for every t by 2 time. Okay. Now here if you observe here, so for t by 2 time, the polarity of the voltage signal is positive and the polarity of the voltage signal is negative for the next half of the period. So the same thing will continue for the next time period and goes on, right? It is going to get repeated for the next time intervals also. Okay, so for each and every t by 2 here, half of the period, the polarity of the voltage signal is going to change. So that is the second point here. So for every t by 2, the polarity of the voltage signal is going to change. Okay, so this is the second property. And what is the third one here? See here. So in the positive half cycle, whatever the shape that you are seeing, whatever the shape of the signal that you are seeing in the positive half cycle, the same shape has to be maintained in the negative half cycle also. The same shape has to be maintained in the negative half cycle also. So whatever the shape it is maintaining, or I can say whatever the values the voltage signal is taking at each and every instant, during the positive half cycle, the same negative values it has to take during negative half cycle also. Okay, so whatever the values of voltage it is taking for each and every instant of time during positive half cycle, the same negative values it has to take during negative half cycle also, right? Okay, so that is the third point here. So what is the third point here? So whatever the values the signal is taking during, or you can say tracking or something, okay, or tracing or something, okay. So whatever the values the signal is taking during positive half cycle, that is over T/2 period here, over T/2 period, okay. So same whatever the positive values the signal is taking during the positive half cycle, the same negative values it has to take during negative half cycle, So that means what here? What do you mean by this? Whatever the values it is taking during positive half cycle, the same negative values it has to take during negative half cycle. What do you mean by this here? That means the shape of positive half cycle and the shape of negative half cycle must look what? Must look same. So that's what this statement mean here. Okay. So this is the third point here. And finally, the main important point here. Is, so this line here, So if you move along this line, that means if you move along this line here, what is voltage value along this line here? The voltage value along this line is 0. Yes or no? If you move along this line, the voltage value is equal to what? The voltage value is equal to 0. Okay. So here the main property of pure AC signal, is the average value here, the average value of pure AC signal, is always equal to what here? Is always equal to what? Is always equal to 0. It has to be maintained here. So the average value of pure AC signal is always equal to what? Is always equal to 0 here. So these are the things that the AC signal, pure AC signal has to satisfy. What is the first point here? It must be periodic in nature. And what is the second point? For every T/2, the polarity of the voltage signal is going to change. And whatever the positive values the signal is taking during positive half cycle, the same negative values it has to take during negative half cycle. That means the shape during positive half cycle must look similar to the shape during negative half cycle. Okay. Next, fourth point, the average value of pure AC signal is always, or you can say must be equal to what? Must be equal to 0. Right. Okay. Now similarly, if you consider this current here, okay, so here whenever the polarity here is plus and minus, the current direction is in clockwise direction. Whenever the voltage signal is changing its polarity, the current direction here for the next T/2 is in anti-clockwise direction, right? So that means if you are saying pure AC current signal, means it has to satisfy all these properties here. But instead of writing here for every T/2 the polarity of voltage signal is change is going to change. Instead of this, you can replace this with what? You can replace this point with, for pure AC current signal, you can replace like this. Okay, so for every t by 2, for every t by 2, the direction of the current signal, the direction of the current signal or current flow. Okay, the direction of the current signal or current flow here, the current flow in the circuit, for every t by 2, the direction of the current signal is going to change, is going to change. Okay, is going to change. It has to be changed for every t by 2. So for every t by 2, the direction of the current is going to change here. For half of the period, it is flowing in clockwise direction, means for the next half of the period, it is going to flow in anti-clockwise direction. It is going to flow in anti-clockwise direction. So all other conditions will also must be satisfied for pure AC current signal, right? Okay. So whenever you are saying voltage, we are saying the polarity of the voltage signal has to change. Whenever you are saying in terms of current, you are saying the direction of the current has to change. Okay, for every half of the period, right? Okay, so is it clear here? Is it clear? Tell me. Yes or no here? Is it clear here? Is this point clear? Is this points clear here? So give some comment in comment box here so that I can understand. Yes or no? Is it clear? Okay. Okay, yeah. So I hope it is clear here. I hope it is clear. Next, here, see here, if you observe here, I have told here the average value of a pure AC signal, must be always equal to what? Must be always equal to 0. The average value of pure AC signal must be equal to 0, right? Okay. So what do you mean by this? What do you mean by this? So we try to understand what do you mean by this average value? What do you mean by the average value of pure AC average value? Okay, so the average value of pure AC signal is always equal to what? Is always equal to 0. So next we will see what do you mean by average value? What do you mean by average value? What is the purpose? What is the purpose for calculating the average value? What is the purpose of calculating average value? Okay, okay, we will see that here. We will see that. See here, the main purpose of average value, I will tell you with some analogy here, with some analogy. Okay, I will explain one example so that you can understand the concept behind this average value. What is the purpose of average value? Okay, see here, if suppose, let us consider any college or something here, some college or something. Okay, so now let us say a principal has visited to a classroom. Okay, so there a physics teacher is teaching the class. Let us assume physics teacher is teaching the class. Principal has attended to that classroom and he has asked the physics teacher in the recent exams, what is the performance, how is the performance of the students in physics exam? What he has asked here, principal has asked to the teacher that how is the performance of the students, in physics exam, that means what is the marks they have scored, like that. Okay, so he asked something here. So then if suppose in that case, if suppose the teacher starts explaining to the principal, if suppose explain to the principal like this first person. Let us assume that classroom is having some 200 students here. Let us assume that classroom is having 200 students, and the principal is asking to the teacher what is the performance of these 200 students in physics exam. Okay, then if teacher starts explaining like one person, the first person has got 70 marks out of 100, and second person has got some 75 marks, and third person has got some 20 marks, and fourth person has got some 50 marks, and so on. If she start explaining for the overall 200 students, then what happens to the principal here? He will get mad or not? Yes or no? Okay, so he cannot explain what is the performance of each and every student, or what is the marks that each and every student has got. Okay, so instead of that, what he can do here, he can say on an average in physics exam, my whole students, that is whole 200 students, has got on an average a marks of 75. Marks. So this is the average value. This is the average value of all the students in physics exam out of 100. Okay, so instead of saying the performance or the marks of each and every student, okay, you can simply say on an average the overall class has got 75 marks in physics exam. Then your principal will also understood, okay, 75 marks means somewhat it is better performance in physics. Okay, so like that he can estimate, or he can get some brief view, okay, of the performance of the students in that particular exam. That means the whole data here, whatever the data you are having, the whole data is interpreted or represented in terms of what? In terms of single value or not? It is represented in terms of single value. And this value, if I say something like this average value, then it is easily understandable, right? Yes or no? Okay, so the whole data, instead of expressing the whole data can be interpreted or represented with a single value. So whenever I am saying some average value, you can understand, that means it is giving some information about this whole data. So on an average they got 75 marks. Okay, so some persons may got more than that, and some persons may got below this average marks, right? So it is going to vary above average and below average, but overall this average marks is going to give you some brief idea about the performance of the students here. It is going to give some information about the whole data. Right or no? Right or wrong? Yes or no? So you can represent with a single number. Right? So that is the advantage of representing what? Of representing average value. And always remember, this average value is always less than or equal to peak value here. Peak value. Average value must be always less than or equal to what? Must be always less than or equal to peak value. It will never exceed the peak value. Suppose here the highest marks that the student has got 95 marks. Let us assume 95 marks he got. So this is the peak value, right? Yes or no? So this average value will never cross this 95 marks here. Will never cross this 95 marks. It cannot be more than the peak value. It is always less than or equal to what? Peak value. Now here we will see how we have calculated this average marks here. Okay, so what we have done here is we have added up the marks got by each and every student. And we have divided that with the total number of students. So what we have done, we have added, okay, so the marks of how many students here? Some n students. Marks of some n students, where n is varying from 1 to 200. So you are adding the marks of n students, where n is varying from 1 to 200. Next you have to divide this. With the total number of students, that is 1 by n. So if you do this, what marks of 1 means what here? So marks of first person plus marks of second person plus marks of third person plus and so on. So if you add up all this and divide with the total number, you are going to get what? You are going to get average value. You are going to get average value. Let us say you got some 75 marks. Understood? So the whole data you can represent in terms of what? In terms of a single value. Right? Okay. So this average value doesn't represent the marks of any particular student here. It is going to represent, it is going to give you the information about the whole data. So it is constant. It is some constant value. Right? Okay. So now, okay, here here you have done summation like this. Okay, it's fine. Okay. Now if suppose how to calculate the average value if you are having a time varying signal. Let us assume some periodic signal here. I am drawing that periodic signal only for one period of time. So let us assume the signal is varying like this. Okay, this is for one period. So the same is going to get repeated for the next period, and it continues here. So let us assume this is one periodic signal. So it is going to continue for the next intervals of time also. So let us assume this is x of t. Now I want to calculate the average value of this periodic signal. Okay, so what I have to do here, how I can calculate? What I have to do? So I have to add up the values of this function at each and every instant of time, overall this time period. So how you can do that here? Here the time is what? The time is continuous. Yes or no? The time is a continuous quantity, right or no? Okay, so it is not discrete here, it is continuous. So you have to add up the values of the function at each and every instant continuously. So that means you have to do what? A continuous summation is nothing but what? Is nothing but integration or not? Yes or no? So you have to integrate with respect to what? It is continuous in time. So you have to integrate with respect to what? With respect to time. So the same thing here, whatever we have done here, the same thing we are doing here. Yes or no? Okay, here it is number of students, it is not continuous. Yes or no? First person, second person, third person, like that. You don't have 1.2, 1.5% like that. Yes or no? Okay, but here time is a continuous quantity, right? Okay, so what you have to do? So you have to add this function at each and every instant over this time period t. So that means you have to perform what? You have to perform the integration over a time period t. See, the average value will always depends upon what? Always depends upon this period. So for how much of period you are calculating the average value. So that is very important here. Here if I change the number of students, then the average value is also going to change. Yes or no? Here if I change 0 to t by 2, if I change the period to 0 to t by 2, then the average value is going to change. So for how much period you are calculating the average value is also very, very important. Okay, now here I am calculating the average value throughout the whole period, that is t. Then what you have to do? You have to divide this with the total time period. So this is going to give you what? This is going to give you some average value of this signal. Right? Okay. So that means finally what you are going to get here? The beauty of this one is what you are going to get. Finally, see here. Here it is a function of time. This is a function of time. So if you integrate something which is a function of time, then the result will also become what? The result that you are getting from here is also nothing but a function of time. Yes or no? You are going to get some function of time here. Let us say x1 of t or something. Okay, something. Okay, so now then what you are going to do? You are going to substitute the range. That is from 0 to t. So that means wherever you are having t, it is a function of time. Yes or no? Once you integrate this one, you are going to get something that is a function of time. Now you have to substitute its range here. That means you have to substitute wherever you are having t in this function, there you are going to substitute these ranges. Yes or no? So finally what you are going to get? Finally you are going to get some constant value or not? Some constant value which is not a function of what? Which is not a function of time. Yes or no? Yes or no? So once you integrate this, you are going to get a function that is also a function of time. So in that function of time, if you substitute the range, okay, so wherever t is present, there you are going to substitute these values, right? Okay, so once you substitute these values, then finally you are going to get what? You are going to get a quantity which is independent or constant with respect to what? With respect to time. That means you are going to get some constant value. You are going to get some constant value, which is nothing but what? That constant value is nothing but the average value. Is nothing but the average value. Yes or no? That is nothing but average value. Right? Okay. So that is the purpose of determining this average value here. So the whole data, or this total or I can say what I can say here. Okay, so the whole information of the signal can be represented with a single value, with a single number or single value that is constant with respect to time. Okay, so that is the advantage of determining what? That is the advantage of determining average value here, average value. So I hope it is clear here. Is it clear here? Yes or no? Is it clear? So that is the purpose of average value here. Okay. Okay, sir, this is how you have to calculate the average value. Okay, fine. So actually what this average value will represent, so that's what we are going to see now. Now if I consider a pure sinusoidal signal here, let us say A into sine omega t, so what is the average value of this pure sinusoidal signal here? What is the average value of this pure sinusoidal signal over its total time period t? Okay, what is its average value? So how to calculate here? Take this function, that is A into sine omega t. Okay, so we have to integrate with respect to omega t. So the total time period, that is 0 to 2 pi, 1 by 2 pi. So in place of omega t, you can replace with theta here. Yes or no? Omega is radian per second, and here second will get cancelled. You are going to get the parameter that is in terms of radians, that is theta. You can represent in terms of theta. Okay, so what you are going to get? You are going to get 1 by 2 pi A, and integration of sine theta is nothing but what? Integration of sine theta is minus cos theta, right? Integration of sine theta is minus cos theta. Its range is from 0 to 2 pi. So take minus common here, then you will get cos 2 pi, that is 1, minus cos 0, that is also 1. 1 minus 1 will become what? 1 minus 1 will become 0. So the average value of this pure sinusoidal signal is equal to what? Is equal to 0. Right? Now if I consider the average value of a DC signal here, if I consider the average value of a pure DC signal, okay, what you are going to get here? That means remove here sine omega t here, If you take simply A, or what you can say here is, wait yeah. Okay, so here that means if you take simply a pure DC signal here, the average value of that pure DC signal will be what? Will be simply that DC only. It is nothing but simply a DC only, DC value only, right? Okay, so that means if you consider average value of 5, then you are going to get 5 only, right? Okay. Okay, yeah. So the average value of DC signal is itself here DC only, right? Okay. Next, if you consider the average value of some DC signal plus pure AC signal. So pure DC plus pure AC signal. Okay, so that means let us consider here pure DC means 5, let us consider here pure AC means let us consider 5 into sine omega t. So if I consider this signal here, which is having both DC as well as what? AC. Now if I try to determine the average value of this one, what you are going to get? You are going to get 5 or not? You are going to get 5. 5 plus 5 sin omega t. For this, the average value will go to 0. For this one, it will be 5. So you are going to get 5 here. You are going to get 5. That is nothing but DC. That is nothing but DC. So whenever you are calculating average value, what you are getting here? See here. Here average value of A sin omega t. Here I can add some 0 here. So this is 0. I can call it as what? I can call it as DC. Yes or no? It is also constant with respect to time or not? Okay, I can call it as 0 DC. So here you are getting 0, which is nothing but what? Which is nothing but DC only. Which is nothing but DC only. So that means if you consider a signal, that signal may have what here? That signal may be a combination of what? Both AC signal as well as what? DC. It may be a combination of both AC and DC. Yes or no? Okay. So in that case, if you try to determine the average value of that particular signal, then the output that you are getting, what? The output that you are getting is nothing but simply a DC value. You are getting some DC. So that means whenever you try to find out the average value of any signal, it is going to give you what? It is going to give you the DC component that is present in that signal. It is going to give you the DC component that is present in that signal. So this is very, very important here. This is very, very important. So whenever you are calculating, so write down that point here. So whenever you are calculating, or you can say simply the average value of any signal, any periodic signal. Okay, it must be periodic. Okay, so the average value of any periodic signal will give you the DC component, present in the signal. It is going to give you the DC component present in the signal. Okay, so the average value of any periodic signal will give you the DC component present in that signal here, So this is very, very important here. This is very, very important. Okay. Okay, yeah, fine. So this is all about average value here. So next see here. Next we will see what is the purpose of determining RMS value. Okay, see here. Now suppose I am considering a circuit here. Let us say here it is V of t, and here you are having a resistor. R. Right. So it is going to pump the current in clockwise direction for t by 2 time. And for the next t by 2, it is going to pump the current in anti-clockwise direction for next t by 2. Right. Okay. So now let us assume this is pure sinusoidal here, or pure AC signal. Okay. So now here let us consider V of t is equal to Vm into sin omega t, and here I of t is equal to Im into sin omega t. Let us consider. Right. Okay. So now if you try to draw the signals here, so let us say this is t. Okay. So Vm sin omega t. So this is Vm and this is minus Vm, right? Okay, so this is V of t. Okay, next similarly I am drawing for I of t. So this is I of t. So I of t So I of t is equal to what? I of t here is equal to what? Is equal to V of t by R, V of t by R, that is Vm sin omega t, Vm sin omega t by R. Here Vm by R I am replacing with simply Im. Okay, so Im into sin omega t. So I am representing the same here. Okay. So you are going to get some signal like this, right? Okay, okay. So that means, see here, see, whenever, okay, so whenever the voltage is having this polarity, okay, it is going to pump the current in clockwise direction. So this current is going to flow, through this resistor. So whenever the current is flowing through this resistor, some heat will be dissipated, yes or no? Some energy will be dissipated in the form of what? In the form of heat, yes or no? Some energy will be dissipated, or you can say power will be dissipated, right, in the form of heat, Okay, during negative half cycle, what will happen? The current is going to flow in anti-clockwise direction. So whenever the current is flowing through the resistor, in that case also you are going to have what? You are going to have power dissipation. Across R. So that means over a time period T, okay, so there will be a power dissipation. Across what? Across R. Right? Okay. So the power dissipation is occurring across R over a time period T. So whenever during positive half cycle the current is flowing like this, the power is dissipating. During negative half cycle the current is flowing in anti-clockwise direction. In that case also the power is dissipating across the resistor. Right? Okay. So so that means the power that is dissipating across the resistor is not equal to 0. It is having some value over a time period T. Now here, see here. If I try to draw the power here, okay, that is P of T. So here, with respect to time. So now what you are going to get? Tell me what you are going to get. P of t, I can write it as what? I can write it as V of t into what? Into I of t, right? So this P of t is nothing but V of t into what? Into I of t. So just multiply these two here, What you are going to get? You are going to get plus into plus will become plus. So you are going to get waveform like this. So minus into minus will become plus. Right, here plus into plus will become plus, so you will get the waveform like this. Yes or no? Okay, so this is the power that is dissipated, across the resistor during each and every cycle, right? Okay, so now see here. If you try to calculate the average value of the signal here, is equal to what? The average value of the signal is equal to 0. It is pure sinusoidal waveform. Yes or no? Pure sinusoidal means it doesn't have any DC component. That means average value will become equal to 0. So for this one also, it is also pure AC signal. Okay, so there will be no DC component. That's why the average value here also you are going to get what? Average value you are going to get 0. But for this one here, okay, you are having you don't have the negative half cycles. Yes or no? It is not pure AC, right? It is not pure AC. It is pulsating DC. Right? So the P average here, over a time period T. So the average value of the power that is dissipating across the resistor is not equal to what? Is not equal to 0. It is not equal to 0. Right? Okay. So now here the P of t, that is instantaneous power, I can represent it as Vm sin omega t into Im sin omega t, that is Vm Im into what? Into sin square omega t. So here Vm I can write it as what? I can write it as Im into R. So you can represent this as Im square into R sin square omega t. So this is nothing but what? This is nothing but P of t. That is, it is going to give you the instantaneous power here. It is going to give you the instantaneous power. Okay. So now here I want to represent this power here. I want to represent this power in terms of what? In terms of average power. In terms of average power. So I said whenever you are calculating average of some signal, you are going to get what? You are going to get some constant value. Yes or no? So you have to get, if you calculate the average value of the power, you have to get some constant value that is constant with respect to what? That is constant with respect to time. So whatever the value that you are going to get here, it must be independent of time. That means it should not be a function of time. It is going to be some constant value, right? Okay, that's what you mean by P average. Yes or no? Okay, now here if you calculate DC power here, if you calculate DC power, how you can write the DC power here? I can write the DC power as DC voltage multiplied by what? DC voltage multiplied by DC current. DC voltage multiplied by DC current. Here this V is constant and I is also constant, and hence you are getting P DC is also what? Is also constant. Now here I want to represent this average power here. I want to represent this average power in terms of voltage multiplied by what? Voltage multiplied by current. I want to represent this average power in terms of voltage multiplied by current. So if you multiply voltage and current, finally you have to get some constant value. That is independent of what? That is independent of time. That is independent of time. So how I can get that? How I can get that? See, if you write V of t into I of t, you are not going to get some constant value with respect to time. Okay. So here you want some constant voltage. You have to represent some constant voltage. Here also you have to represent some constant current value. So then only you are going to get P average as some constant. Constant means it is independent of time here. It is not a function of time, right? Okay. So I want to represent in this manner. Okay. So okay sir, we can represent in terms of constant voltage and constant current. We know that the average value will always give you what? The average value of the voltage signal is always give you some constant, that is DC component. Yes or no? And the average value of current is also give you some constant value. So can we do V average? Can we do V average into I average here? Because V average is going to be some constant value, I average is also going to be some constant value, right? Okay. So then if you multiply these two, then can we calculate the P average in this manner? Can we calculate the P average in this manner? See, if you do this, what you are going to get? We have already seen V average is equal to what? V average is equal to 0, I average is equal to 0. So if you multiply V average into I average, you are going to get 0. So that means it is giving the result, which is what? This is wrong. Yes or no? Okay. So the average power that is dissipating across the resistor is not equal to 0. So there is some power that is dissipating across the resistor whenever the current is flowing through the resistor. Yes or no? So it cannot be 0. It cannot be 0. So if you directly multiply V average into I average, it is going to give you what? It is going to give you some wrong result. Yes or no? Okay. So you cannot represent P average in terms of V average and I average. So we need some other parameter. We need to define some other parameter. Yes or no? In order to represent P average in terms of what? In terms of V and I. In terms of V and I. Right? Okay. So what is that parameter? What is that parameter? That is nothing but the RMS value of voltage and RMS value of current. RMS value of voltage and RMS value of current. So what is the purpose? What is the purpose of this RMS value of voltage and current? That's what we have seen here. If you multiply V average, I average, you are going to get 0. Okay. So we need some other parameter that is going to give you P average as some constant. Right? Okay. So now here we are going to define one more parameter, that is RMS value of voltage and RMS value of current. So how we have defined this RMS value? See here. Now suppose you consider a circuit here. You have considered a circuit V of t here, and here let us say this is simply a resistor. Okay. So the current is going to flow through this resistor, that is I of t. Right? Okay. So some power here on an average, that means what I am saying here is the current is flowing through this resistor, so the power will be dissipated. So that means the energy will be dissipated across this resistor. Yes or no? So energy will be dissipated. Energy will be dissipated across this resistor. over a time period, over a time period t, over a time period t, over a time period t. So if the current flows through this resistor in clockwise and anti-clockwise direction over a time period t, then there will be some energy, that is dissipated in the form of heat across resistor here. So what is that energy that is dissipated here? How you can write the energy here? See, the power is nothing but what here? Power, I can write it as I square of t into R. Yes or no? So this is the power that is dissipated across R. Now if I want the energy, that is dissipated over a small interval of time dt, so then what you have to do? See, energy by time is nothing but what? Power. So energy is equal to what? Power into what? Power into time. If you multiply power into time, you are going to get energy here. So this is the power, that is dissipated across the resistor. Okay, I want the energy that is dissipated, within a small interval of time, that is dt. So what you have to do? This power multiplied by this dt will give you the energy that is dissipated over a small interval of time dt. Now if I want the total energy that is dissipated, over a total time period t, then what you have to do? You have to integrate over its time period, So this is going to give you the total energy, dissipated across R in time t, right? Yes or no? In time t. Okay, yeah, fine. Now here I'm going to take the same resistor here. So I am considering the same resistor here, right? I am considering some same resistor here. Now here what I am doing here is, so now I am connecting the same resistor R here. Okay. So now what is the effective value of voltage, or what is the DC voltage? That has to be connected across this resistor? What must be the DC voltage that has to be connected across the resistor such that the energy dissipated across this resistor, must be same as the energy dissipated across the resistor in AC. Yes or no? Okay, so whatever the energy that is dissipated across the resistor in AC, understood? Okay, AC in a duration of time t. So for the same energy to dissipate, amount of energy to dissipate across the resistor R within a time period t, what must be the DC voltage? What must be the equivalent DC voltage that I have to apply across resistor R? So that means I have to apply, I am going to apply a DC voltage here. I am going to apply a DC voltage across the resistor, such that it is going to pump a DC current, across the resistor R, such that if it continues to flow over a time period t, then the energy dissipated across R, must be what? Over a time period t, must be same as what? Same as in case of what? In case of AC. That means in this circuit here. In case of AC circuit. Okay, so what must be this DC voltage that you have to connect across R, such that it has to dissipate the same amount of energy across resistance R over a time period t. So you have to determine this DC voltage. So this DC voltage, we call it as, sometimes we can call it as what? V effective value. What is the effective value of the voltage that has to be connected across the resistor R, such that it has to dissipate the same amount of energy in a duration of time t, Okay, same amount of energy. Same amount of energy means what here? Here whatever the energy that is dissipating, the same amount of energy it has to dissipate. So in order to do that, what must be the effective value of the voltage that you have to connect here? So here this DC current is called as what? Is called as I effective. So what must be the effective current? What must be the effective current that has to flow through resistance R in order to dissipate the same amount of energy, over a duration of time t. So we want to determine that here. So the energy dissipated in this circuit across R and the energy dissipated in this circuit across R in a duration of time t must be same. So in this circuit, what is the energy that is dissipated across R over time period t here? That is nothing but what? That is nothing but simply I square, that is I effective, yes or no? I effective square into what? Into R. So this is going to give you what? This I effective is nothing but some constant value or not, right? Okay, so I square into R will give you the power that is dissipated across R. Now you want the energy dissipated across R over a duration of time t, so that means you have to multiply this power with total time period t. So this is going to give you the energy dissipated across R within time period t. So whatever the energy that is dissipated here, it must be same as what? It must be same as the energy dissipated across R in this situation, in this circuit, right? So this two must be what? This two must be same. So from here we try to determine this I effective value. Okay, now here this R is constant on both sides, so you can cancel this R. Okay, so therefore you are going to get this I effective square is equal to what? Is equal to, I am sending the t to this side, so you are going to get 1 by t into 0 to t, integral 0 to t, you will get I square of t into dt, I square of t into dt, right? Okay, so this I effective is equal to what? Is equal to what you are going to get here? Square root of 1 by t integral 0 to t I square of t dt. Okay, so this effective value we call it as what here? We call it as RMS value. So IRMS is equal to what? Is equal to square root of 1 by t integral 0 to t I square of t into dt, So this is the RMS value of current here. So similarly you can determine, instead of writing here I square into R, you can write in terms of V square by R. Then also you are going to get what? You are going to get VRMS, right? So you are going to get the expression for VRMS as square root of what? Square root of 1 by t integral 0 to t V square of t dt. Right, so this is the expression you are going to get if you try to calculate for VRMS. So if you do this integration here, if you do this process, what is the value that you are going to get? See here, it is a function of t. If you integrate this, you are going to get some function that is you are going to get a function that is also a function of time, yes or no? Now if you substitute its range here, once you substitute its range in that time, okay, you are going to get what? You are going to get some constant here. So finally you are going to get this I value is nothing but what? I value you are going to get some constant, yes or no? Okay, and here you are not integrating simply I of t, you are integrating what? I square of t. So that's why you are going to get what? You are going to get some non-zero value here, right? Okay, so here also you are going to get what? You are going to get some constant value, VRMS. Here IRMS is also some constant value, right? Okay, so if you calculate IRMS and VRMS for pure AC signals, it is not going to be 0. You are going to get some value, you are going to get some constant value. Now I can write this P average here. Now I can write P average as what? As VRMS into IRMS. Yes or no? I can write VRMS into IRMS. So this is some constant value you are going to get, and this is also some constant value you are going to get, and P average is also going to be some constant value. So everything is constant with respect to time, right? Okay, so in this manner you can represent P average. Yes or no? So this is the purpose of RMS values. This is the purpose to determine what? In determining this RMS quantities here, right? Yes or no? Okay. So this is the whole story of RMS values and average values here. Okay, so why we are determining average value, what is the purpose, and why we have defined another quantity, that is RMS value, what is the purpose of it. So all these things we have seen, So in the next class here, we are going to apply all these concepts in order to analyze the rectifier circuits, Okay, so before coming to the next session here, that is tomorrow at the same time 10 a.m. okay, you have to go through, or you have to revise this lecture compulsory, right? Okay, so in the next session we will start, or we will see the concepts of rectifier circuits, and also we try to solve some problems on rectifier circuits. Okay, so I hope this is clear here. I hope today's lecture is clear. Yes or no? So is everything clear here? Yes or no? Tell me here. Is it clear here up till now? Chandan Siri, are you providing electrical classes? See, analog circuits is there for both ECE students and electrical students here. Both it is useful. Anyway, these concepts, this average value, this RMS values, all these concepts are very much helpful for you, not only in analog circuits. It is going to be helpful in network theory or signals and systems, whatever it may be. Okay, so these concepts are very much helpful in other subjects also, right? Okay, sir, please make a notes in all topic. See, whatever I am writing here, you can write a running notes. Okay, so or otherwise you can see the videos again, and you can put a pause button, and you can write the notes for each and every point here. You have to prepare the notes here, right? Okay, if you prepare the notes on your own, it is going to be very much beneficial for you. Okay, so whenever you are revising, it is going to be very much helpful for you to revise all those concepts. Okay, so I hope today's lecture is clear. Okay, so with this I am winding up the session here. So we will meet tomorrow at the same time at 10 a.m. and don't forget, today at 4 p.m. I am going to take another session, that is on EMT. So we will meet in that session here. Okay, so take care guys, bye bye.